Hey guys, this is MacHeads101, and today I'm going to be giving you a brief introduction to automatic reference counting with Objective-C. Now, automatic reference counting basically makes memory management a whole lot easier because the compiler takes over for the developer to manage all your memory. So if you're already an Objective-C programmer, that's really who this video is aimed for anyway, then you'll really be able to see the improvements that this makes. And you will get this new feature when you upgrade to Xcode 4.2. You can enable it for a new project or for your existing projects, and it's really useful. Now, in this tutorial, I'm just going to be giving you a couple examples using a command line foundation application. So we're not really going to be making anything. I'm just going to be showing you some of the things that are different and some examples of how you would use automatic reference counting. I like to call it ARC. That's automatic reference counting, it's an abbreviation. So that's probably what I'll be calling it in this video. So let's go into our new file dialog here, command line tool. I'll hit next. Okay, now I guess I'll call it arc test. Alright, and for type I'll select foundation and make sure to check use automatic reference counting. If you don't have this option, it's because you need to upgrade to a newer version of Xcode. But anyway, we'll hit next one more time. And I'll hit create. Alright, so right off the bat, you'll notice I'll go into here, I'll go into my main.m file. Wait for it to load 1 second. I'll go there. And you will see a couple things that are different from what it looked like before automatic reference counting. Before, there was definitely an auto-release pool declared like this. Let me show you. ns autorelease pool equals ... Well, that is now deprecated. You're not allowed to use that. That is against the rules. Instead, you can only use the @autorelease pool compiler directive, which basically lets you block in your code where autorelease pools are used. Now, this is so that way the developer remembers always to close your auto-release pools and to drain them, because you always have to have a closed curly brace in order for the compiler to actually finish. And another thing is that, let's say you have a variable declared in here that happens to be auto-released. You don't want to be able to accidentally access it outside of the auto-release pool. Now, obviously, you could declare the variable outside of this scope, but it still helps. And it's good for organizing. So anyway, let me just reformat the code the way I like it here. So this is the first feature that people usually notice, is the new way of doing auto-release pools. Now, if you don't know what an auto-release pool is and you're an Objective-C programmer who only works with Mac or iPhone apps or something like that, you don't really need to worry about it too much, but it helps to understand what it is. And since this video is about memory management, I'm going to be assuming that you know what an auto-release pool is. I think that's a pretty valid assumption to make. But anyway, so let's go ahead and I'll just create a new class, and this will be our first test object, I guess. So I will call the class test class, and I'll make it a subclass of NSObject. And I'll go ahead and create it. And here we are. Okay, so this is going to be a very basic class, and I'm just going to be showing you another new feature that you will probably notice most if you're trying to port existing Objective-C code to automatic reference counting. So let's go into here, and you'll notice that there's no methods, first of all, but let me throw in a dealloc method, okay? Before, you would always have to call super dealloc. Well, now the compiler basically maintains the dealloc chain for you. It automatically calls super dealloc for you. It inserts that code when you compile, so you never actually have to write that code, and it doesn't even let you write that code. As you can see, I have an error here. Okay. Another thing that you might do in a dealloc method is set properties to nil, like self.test equals nil. Right? You don't need to do that. It automatically does that for you and releases all your instance variables for you in the dealloc. So most of the time, you won't even have to implement a dealloc method at all. Now, in this case, I'm going to be implementing it just to put an nslog, like object dealloc. Okay, and so this will run when this object is freed, when it's deallocated. Now we can't call release or retain on it because automatic reference counting takes care of that. So I'm just going to be giving you an example. Alright, so now in here, I'm going to be, first of all, getting rid of all this. I'm just going to have test class C equals test class alloc init. Okay, and I need to import test class. Okay, and now here we go. Now obviously I don't use this variable, so I'll just insert this. It's just casting it to avoid, so that way it looks like I use it. This doesn't actually really do anything. It's just that way we ignore that warning. You don't need this line. It's completely irrelevant. I just don't like the warning. But anyway, if you're an Objective-C programmer who knows about memory management, you're probably immediately thinking, oh, this is horrible. He is not calling release, where I would have to do C release. Well, the great thing about automatic reference counting is that it automatically releases all your variables when they go out of scope. Or more accurately, it sets them to nil. So if they would have been released when they go out of scope, then they are released. So I don't need to call that anymore. And if I run it, wait for it to run. Object dealloc. Now, I didn't call dealloc on this object. I didn't really do anything. But the compiler is smart enough to realize, okay, I'm getting out of this auto release pool, and I still have C allocated, and it inserts C release. Okay? So that is the most basic, fundamental feature of automatic reference counting, is that you cannot call release, and it knows when it's going to release things. Now let me do a little more advanced things. I'm going to have, one second, I'm going to make another class. So let me just create another class. And I will call it another class. And I spelled another wrong, but since this is an example, I'm not even going to bother fixing that. It is just another class. Okay, good. So let's go ahead in here. And we're going to basically do the same thing. We're just going to have another dealloc method, aslog, another dealloc. And in the spirit of typos, I spelled another wrong again. That was actually accidental, but it turned out really nice. So, excellent. Now we're going to have another class with an instance variable. So in another class.h, we're going to import test class.h. And then we're going to have an instance variable of test class, a test. Okay, and now we're going to have a method. Sorry, one second. Init with test. Test class, a test. Okay. And now we'll also make a property for this, just so that way they don't have to use the init method, because we're going to be doing it both ways just for testing purposes. So, non-atomic retain test class a test. Okay. Now let's go ahead and I'll implement this, and I'll also synthesize a test. And I'll have my init method here. Still have to call super init. I am just eagerly awaiting the day when they fix that, or, you know, basically get rid of the need to do it. But okay, so now we can say a test equals, let's say, underscore a test, and I'll change the name of the parameter to underscore a test. Alright, that's okay. Great. Now, you will see two things. First of all, I'm not even bothering to do self.atest equals underscore a test, even though I know if I do self.atest, it'll retain it. And that is because instance variables that are just declared like usual instance variables will automatically retain themselves when I assign them. And they'll automatically release themselves either when the object that contains them is deallocated itself, or in some cases when they're set to another value or set to nil. So that's all good. We don't have to worry. We don't even have to release this in dealloc or anything. this is how it all should be. And now we're going to create another test equals another test alloc. And one second, let me import another test before I go on. Init with, what did I call that method? Init with test. Okay. And now I have a nice good old instant of another test. Now, I'm going to replace this with test because it's going to be unused. And now let me fix this problem. Oh, it's another class. Excellent. Alright, well, anyway, regardless of that, I have this now set up. And now this should retain C. And if we are correct, C will still be deallocated because this will still be deallocated as well. Because it'll go out of scope and be, deallocated, whatever. So there we go. First, another class is deallocated, and then our original object is deallocated probably in the same dealloc method. But first we call the log, and then the compiler inserts all our dealloc code, whatever. So that is excellent. Now, instead of doing init with test, let's just try init, because maybe the init method does something magical. Although I wouldn't lie to you, but, let's give that a shot. So what did I call it? It's a test. A test equals C. And I know my naming convention isn't the best for these tutorials, but it doesn't much matter because I'm not really distributing this code in any way. So we have the same results. So that is evidence that basically instance variables get deallocated. Now I'm going to be introducing you to another type of instance variable or of ownership qualifier that you can use. So right now we've only been working with the strong ownership qualifier, and that is basically the equivalent to a retained property. So a test is right now of the strong ownership qualifier, which means that it will retain its value and release its value. There are other ownership qualifiers. For instance, the unsafe unretained ownership qualifier. What this does is basically it doesn't retain it, it doesn't release it, and it does absolutely nothing to secure you. So let's say I have this instance variable that references a test, and then something else like a test goes out of scope and it's deallocated, and then I try to do something with a test. It'll still be a pointer, but to a deallocated object, so that'll be messed up and everything will be bad. And Apple realized unsafe unretained is a really bad idea. So they added another thing along with that called weak. Weak references are the same thing, except when an object is deallocated, everywhere where there's a weak reference to that object, that weak reference is nulled out. So here's going to be my example for this. I'm going to have underscore underscore weak, and then underscore underscore weak here. Alright, great. And now, let's just have a look. 1 second. Oh, I don't need the double underscore. Just for the ownership qualifier there, but for properties, no double underscore. Alright, and now let's go into here and change a couple little things. So first of all, we're going to declare test outside of here. There we go. Okay, and I will log test, I will log test.atest here. And then I will also log it right outside of this auto-release pool. Now, if you can already tell what's going to happen here, you're in really good shape, but I'm going to show you so we can explain it. So we go here. The first time, it actually logs the test class that we have, and this is just the default thing that'll come out when you log an object if you don't override anything. But then that object is deallocated, and then the next time, outside of the auto-release pool, that we log the same thing, it's null. And that is actually because if you have a look over here, it's because this thing does not retain the test class. It has a weak reference to it. So basically what goes on here is it says, okay, here's C. It has a reference count of 1. And then it assigns that to this property. It still has a reference count of 1. It prints it out. It gets to the end of the auto release pool scope, and it says, okay, C has a reference count of 1, so I don't need to retain it anymore. It's okay. I'm going to release it. So it inserts this code still. Then, when it's released, the runtime automatically goes to this class. It knows about this instance that has an instance variable or a property set to this, and it goes right ahead and sets that pointer to nil. And then the next time I log it, it's nil because of the way it works. Now, if I were to make this unsafe unretained, and I'm not actually sure what will happen, it could work because you know, artifacts are still in memory, or you know, who knows. But let's go ahead and give this a whirl, and I'll make that a sign. That's the equivalence of that. And now let's go ahead and run it. And there we go. So the second time I print it out, it seems to still work, and it doesn't actually work. You can see it actually crashes right here because it's confused and it auto releases that and it does all this stuff and it's messed up. So unsafe unretained is a really bad idea. Either use strong or weak. Very simple, very straightforward. The only dilemma to using strong or weak, of course, is that it's completely runtime dependent. So weak references don't work on iOS 4. They don't work on Snow Leopard. So I try to stay away from weak, and you should never have really unsafe unretained references that will have this scenario, but it will happen on occasion. So anyway, that's just my little gist of how automatic reference counting works. There is more stuff with blocks and other stuff like that that I will probably show you in another tutorial, but not in this one. So I hope you learned something. If you did, great. Go ahead and leave a comment, like the video, whatever. So thanks for watching, subscribe, and goodbye.